Living in Florida, we all probably are aware what humidity is. But in this video, we're going to talk about air temperature and the amount of water vapor that's needed to saturate or completely fill the air. When we're talking about humidity, we're talking about the amount of gaseous water that's found inside of our air. And air can either be saturated or unsaturated. Most of the time it's unsaturated. It has some water inside of it, but it's not completely full of water. But on the other hand, saturated air is air that's holding the maximum amount of water vapor that it can hold. It's at its capacity. But the capacity of air is going to be very dependent on its temperature. We see that warm air is capable of holding more water vapor than cold air is. And that would make sense thinking about Florida. We're a very warm state, and we're also very humid. That's because that warm air is capable of holding more water vapor, increasing the humidity. If we lived in a really cold area like Antarctica, there the air is at such a low temperature it can't hold very much water vapor. And it very rarely ever rains or snows in Antarctica. Whereas here in Florida, at least during the summer, it's going to rain every single day. There are two major ways that we can measure humidity, but it's going to depend on whether you're a scientist or a weatherman, or if you're an average person. So if you want to be really precise, like the weatherman or a scientist, you would want to measure humidity looking at the mixing ratio. This is going to tell us the mass or the weight of water vapor in the mass of the air that it's inside of. So this is a very specific, we measure it in grams per kilogram, but most of the time, the average human doesn't really know what this mixing ratio means. If you tell me there's 2 grams of water vapor inside of every kilogram of air, I don't really know what that means. But if I check my phone and it tells me that we have 92% humidity today, I know what that means. That's relative humidity. That's going to tell us a ratio of the water vapor inside of the air with the amount compared with the amount of water that would be required for that air to be completely saturated. So it's just a ratio of how much water is in the air right now compared to the maximum amount of water that that air can hold. And once we reach 100% humidity, that air is at capacity. It can't hold any more water vapor. So at 100% humidity, that's when we have some form of precipitation. Since relative humidity is expressed as a percent, we can very quickly figure out how much water vapor is being held by that air and whether it's close to capacity or not. So for example, if we're looking at air with 25% humidity, it's holding 25% of the maximum amount of water it can possibly hold, meaning that it can still hold a whole lot more water. But on the other hand, something that's common here are 90% humidity days. This is telling us the air is already holding 90% of all the water it can hold. It can only hold a little bit more before it reaches 100%. And we have precipitation occur. But relative humidity can be changed in 2 ways, either by changing the temperature of the air or by changing the dew point temperature. So since the humidity of air is controlled by the temperature of the air, if we start lowering the temperature, making it colder, that air cannot hold as much water vapor as it could when it was warmer. So by lowering the temperature, we're actually going to be increasing the relative humidity. Because it can hold less water overall, being colder, it's just holding a higher percentage of that water now. But the other thing has to do with the dew point temperature. And this would happen if we had some air that was cooled down to the point that it's going to reach 100% saturation and it will always rain. This map is showing us where those dew point temperatures are on a September day. So September, it's still fairly warm here in Florida, and we can see down here that the air would need to cool to 70 degrees Fahrenheit in order to have rain. Which makes sense. We get a lot of rain on relatively cool days in September. But let's look out west, like in Arizona and New Mexico. In order to get precipitation in this really arid region, the air would have to cool down all the way to 20 degrees, which is very unlikely. And this is another reason why we find those deserts